All right, now we're beginning section 11.4 on a specific type of probability. We're going to work on binomial probability, and it requires the utilization of a formula. So at the top of the page here, how we calculate binomial probability is we use a combination n choose x, p to the x, q to the n minus x. This idea of binomial probability is the idea that we are repeating the same event over and over again, and we want to see a certain outcome a set number of times. So let's go through each of these letters in this formula and describe them. N, listed up here, is the number of repeated trials. P is equal to the probability of success on any one trial. Q is always calculated by taking 1 minus P, or the exact definition of Q is the probability of failure on any one trial. And X equals the number of successes that must occur. So let's look at one that pretty much tells us everything we need and just write how the formula looks. So assume that each of n trials is independent and that P is the probability of success on a given trial. Use the binomial probability formula to find P of x when n is 9, x is 5, and P is 0.15. So I usually like to write on the side n, x, P, and Q, because these are the things I need to utilize this formula. So n is 9, x is 5, p is 1 minus 5. The formula, p is 0.15. Q is 1 minus p, so this is 1 minus 0.15. So this is 0.85. Now to put into the formula, we are finding p of 5. So what that means is out of 9 attempts, we want to see something happen 5 times exactly. We don't care when it happens in the 9 trials, but we want it to happen 5 times. So it's going to be 9 combination 5, 0.15 to the x power, so x is 5, times 0.85 to the n minus x. So n is 9, x is 5, so 9 minus 5 is 4. These two numbers here should add to the first number written before your combination. We want something to happen 5 times. It cannot happen 4 times to make 9 total trials. Now with your calculator, you'll compute 9C5 and then multiply it with the rest of this. But if you have a TI-84, the calculator will do it all for you, right? So you can go to Second Math. Oh, that's wrong. Hold on. My fault. Let's clear that out. You go to Second VARS, VRS, and then you're going to scroll down until you find Binom PDF formula. All right, so it has the whole formula built for you. So I'm going to hit enter, and then it's going to ask me some certain things, so I'm going to clear these out. So the number of trials is 9. I'm going to hit enter. My P is 0.15. Notice it won't ask you for Q because it knows what Q is if you tell it P. And then my X value is 5. I'm going to hit enter, enter, enter. And there's my answer, 0.005. So again, with the TI-84, that was found at second vars, and then you scroll down to BINOMPDF. And then you type in what it wants. So let's try one without them giving us the exact N, P, and X already. So a coin is tossed 7 times. Find the probability of successfully obtaining exactly 4 tails. Successfully obtaining are key words to look for to know that this formula is needed. So again, I'm going to write on my paper N, X, P, and Q. N is how many times I'm tossing the coin, 7. X is how many times I want to see something exactly, 4. Well, what do I want to see exactly? I want to see a tail. P is the probability of seeing tails if you only got to flip the coin once. Well, that's 1/2. And Q is 1 minus 1/2 and also 1/2. So now we plug into the formula. So we do 7C4 times P to the X, so we take 1/2 to the 4th, times Q, which is also 1/2 to the N minus X, or 3. Remember, these numbers right here should add to the total number of trials. Now, either with your Texas Instrument 84 calculator or a calculator that you have to do all these pieces and multiply together, you'd get 35 over 128 or 0.273 if you're looking for a decimal. All right, a fair coin is rolled 8 times. A number less than 3 is considered success, while all other outcomes are failures. Find the probability of 1 success. So we're going to do N, X, P, and Q. N is the number of times we are going to roll the die, which is 8. X is how many times we want to see something exactly. So X is, we want probability of 1 success, so X is 1. P is we want a number less than 3. A number less than 3 is considered success. So if you remember your sample space, how many numbers are less than 3? 2. So P is 2/6 or 1/3. Q is 1 minus 1/3 or 2/3. So now in the formula, we're going to say 8C1. We're going to do 1/3 to the first power, and we're going to do 2/3 to the 7th power. With your calculator, you'll get 0.156.